Oh, we're not doing derivatives anymore.
Oh, we are.
Oh,
So here we go. Example 4 says use analytic methods to find the absolute extrema. But before we begin, let's think about the function that they give us. This is a
parabola.
quadratic function, meaning it is a parabola. It opens up because the x squared is positive, therefore the vertex is going to be a minimum, and on the left side of the vertex the function will be decreasing, and on the right side of the vertex the function will be increasing. So now let's go ahead and jump in, do the calculus. I need to find the derivative. So my derivative of x squared minus x minus 12 is 2x minus 1. 2x minus 1 is never going to be undefined. It's a linear function. There are no holes in or asymptotes. It is equal to 0, however, so I'm going to solve for that point, and that is going to give me x is equal to 1/2.
So that's the answer?
That is not. Because they asked me to find the absolute max and the absolute min. So I'm going to make my consider list. And the consider list is made up of the critical points and the endpoints. In other words, the absolute max or the absolute min has to be either a critical point or an endpoint. These are the only 3 possibilities in this instance. And probably not necessary in this case, but I'm going to go ahead and do my sign charts. Even though I already know, since this is a parabola, I know that this is going to be negative and this is going to be positive, since it's a parabola that opens up. However, you can look at it. If I pick a point between -1 and 1/2, let's say 0, and I plug it into the derivative, I would get 0 minus 1, which is negative. And if I pick a point between 1/2 and 4, let's say 1, and I plug that in, I get 2 minus 1, which is positive. Okay, so now I need to find which one of these points is the absolute max and which one is the absolute min. And I know that they exist because of the extreme value theorem. I have a parabola, which is continuous. I have a closed interval, so there's got to be an absolute max and there's got to be an absolute min. Which one is which? Well, the absolute max will have the highest y value. That makes sense? And the absolute min will have the lowest y value. So what I'm going to do is I'm going to take these values and plug them back into the original function, because that gives me the y value. So if I take -1 and plug it into the original function, let's see, that's going to give me 1 plus 1 minus 12, which is -10. And then if I plug in 1/2, I get 1/2 squared, which is 1/4, minus 1/2 minus 12. So that should be -12 and 1/4. And then if I take 4 and plug it in, I'm going to get 16 minus 4 minus 12, which is 0. And so now I can identify the absolute max and the absolute min. So I have an absolute max. It's going to be this one, because 0 is higher than -10 and -12 and 1/4. And the absolute minimum is going to be at 1/2 and -12 and 1/4, because that value is less than -10. Any questions that I can answer on that example? Okay, let's look at the next one. I have g of x is equal to x raised to the 3/5. And notice that here I have x greater than -2. So it is not closed, meaning that EVT does not apply in this instance. It is possible that EVT does not apply and the function still has an absolute max and an absolute min, but possibly not. Okay. So I'm going to take my derivative. What's the derivative of x raised to the 3/5? 3/5 x to the -2/5. Power rule. And I'm going to simplify this to make it a little easier. So that's going to be 3/5. And then my negative exponent moves this to the bottom. So I'm going to write this as the 5th root of x squared. Now I'm going to check for when g prime of x is equal to 0. And in this case, that would be never. Why can my derivative not be equal to 0? The numerator is, the only way the fraction can be 0 is if I have a 0 on the top, and 3 is in the numerator. There is no variable, therefore it can never be 0. G prime of x can be undefined, however. And so I'm going to set the denominator equal to 0 and solve for x. And if you do that, you should get x is equal to 0. So now I'm going to make my consider list. And I can leave out x is equal to -2 because it is not in my domain. And I've got a potential critical point at x is equal to 0. And I have another endpoint at x is equal to 3. So now I want to make a sign chart also in this case because it will help me a little bit. You will notice that the variable in the denominator is squared. Therefore, it is always positive. And my numerator is also always positive. So that tells me that my function is increasing on this domain. So if this is the case, where's the absolute max? It has to be at 3, right? Because the function is increasing over the entire interval. So if I take 0 and plug it into the original, it's going to give me 0, 0. And if I take 3 and plug it in, it's going to give me 3 raised to the 3/5. Therefore, I have an absolute max at 3 and 3 raised to the 3/5. And there is no absolute minimum. And there's not an absolute minimum because it is an open interval at -2. So let me explain that sometimes students don't realize exactly why that is true. So let me explain that a little bit. So let's say I have a function. It's got an open circle right here, and it goes up like that. So what is my lowest value? Right before the circle, you say, like, let's say it's 0.01. What about this? Could it be that?
Yeah.
Could it be that? Is that defined for the function? Yes. Can I keep going? Sure, because it gets infinitely close to 0, but it never gets there. Therefore, it does not have a minimum value. That's why for EVT to apply for the extreme value theorem, the interval has to be closed. Okay, if it's not closed, As it's not in this case, then I will not have a minimum value.
Maybe you're saying for the max.
If it were reversed, yes. Okay,
So. why-
well, let me back up and say this. If for the endpoint on the other side were open, it is possible that it still has a max. Okay, but EVT would not apply. If the function is increasing on its domain throughout the whole time, then yes, you are correct. It would not have a max. But what I'm saying is, just because there's an open circle there on the endpoint does not necessarily mean that it does not have a max.
Wait, so when would there be a max? Like if there's an open circle? Like, what do you mean by that?
Does that have a max?
Oh, okay, yeah.
See what I'm saying? But that would not be true in this case, because this would imply the positive on the sign chart there, that the function is increasing over its whole domain. So if the function were increasing, then no, it would not have a max. But it is possible in other instances, if the function is decreasing, that it could have a max.
Okay, and why'd you put 0 again? Because like the other one you put 1/2.
Well, I put 0 because a critical point is where the derivative is either 0 or undefined. And if I plug in 0 to the derivative, that will make the denominator equal to 0, and my derivative would be undefined. So 0 is a critical point.
Okay, I got it.
Okay, here we go. 2 more to go. This one, g of x is equal to e to the negative 5x squared. I'm going to find g prime of x. So what's my derivative? It'd be e to the negative 5x squared times the derivative of the exponent, which is negative 10x. And so I'm going to clean this up a little bit. The negative 10x stays in the numerator, and then because this has a negative exponent, it's going to go to the denominator and give me positive 5x squared for my exponent. So now I want to check when g prime of x is equal to 0. And so looking at the numerator, I set negative 10x equal to 0 and solve for x. And that's going to be at x is equal to 0. And now we need to check to see if my derivative is undefined. So that's an interesting question. Is there any value of x that will make the derivative undefined?
No. Yes.
It's one of those.
No.
What about it? What happens if I plug in 0 for x? Then I would get e raised to the 0 power, which is 1, right? And the variable is also squared. So it's always positive, correct? So the answer to this is
No.
none.
Uh-huh.
There's no value of x that will make it undefined. So now I'm going to go to make my consider list, and I'm going to include the endpoints, -1. I'm going to include 0 as a potential critical point, and the other endpoint at x is equal to 3. And a sign chart here just may help to look at it. They're not asking about increasing or decreasing, but I've got -1, 0, and 3. And I would plug into the derivative here. So notice my variable is squared in the denominator. So my denominator is always going to be positive. So I can ignore that for a second. I'm just looking at the numerator. I plug in -1/2, for example, I get -10 times -1/2, which is positive. And if I plug in 1, for example, it's going to give me -10, which is negative. And so I know from my sign chart that 0 is a maximum, right? Because it's increasing, then it's decreasing, goes up, then it goes down. So 0 has to be a max. I'm not quite sure if it's the absolute max, however, okay? So I'm going to take these values and plug them in and see which one of the y values is the highest. All right, so if I take -1 and I plug it into the original equation, I'm going to have e to the -5th times 1. So that's going to be e to the -5. And then if I take 0 and plug it in, I get e raised to the 0 power, which is 1. And then if I take 3 and plug that in, that's going to give me 9 times -5. So I would have e raised to the -45th. And so which one of these is the highest y value? I've got e to the -5th, 1, and e to the -45. It's going to be this one. So this one is my, sorry, I ran out of room there, my absolute max, because 1 is larger than e to the -5th and e to the -45.
So this you only put in the denominator, right?
I'm sorry?
You only plug x in the denominator.
Wait, are you doing the derivative equation or the original?
Oh, the original.
Okay,
What if you
so
plug in-
let me back up and clarify, okay? If I'm doing a sign chart and checking increasing or decreasing, I'm plugging into the derivative. Because the derivative is the slope, and the slope shows me whether it is increasing or decreasing. If I'm checking for the absolute max or the absolute min, I'm looking for a y value, because the highest y value is the absolute max. And I get the y value by plugging it back into the original equation. And so when I did that, I get these 3 y values, and of these 3, 1 is the highest, therefore it is the absolute max, because the absolute max or min has to be either a critical point or the endpoint. So to get the absolute minimum, I'm going to look at these two, and e to the -45 is lower than e to the -5th. Therefore, this is the absolute minimum. All right, well, one more to go. It's a little AP problem, no calculator, so
We can do
welcome
all
to
of-
the
we can do
calculus
all this
jungle.
With a calculator though.
It says the function g is given by g of x is equal to 4x cubed plus 3x squared minus 6x plus 1. What is the absolute minimum value of g on the closed interval from -2 to 1? So I need to get the derivative. G prime of x is going to be 12x squared plus 6x minus 6. My derivative is quadratic, so it's not going to be undefined or have any holes, but it can be equal to 0, so I'm going to set it equal to 0. And now my life is way too complicated, so I'm going to simplify it. How can I simplify this? I'm going to take out a 6. So that's going to give me 2x squared plus 1x minus 1 equals 0. And I can divide by 6 on both sides, and the 6 will go away. And now, oh no.
Yeah. All right.
I'm sorry?
Doesn't that mean x equals 0?
What?
Also?
For, no, it doesn't.
There's a 6 to it.
Not even X at all.
I'm just, no, I'm just dividing by 6 on both sides, and so it goes away.
That's a parabola, there's 2 points, right?
Correct.
It's gonna get 2 points.
So now I have to
Oh.
factor, oh, are we rusty factorers, or yes, we passed algebra 2, so we know how to factor. Let me rephrase. We should know how to factor. But coach, it's got a 2 there. Well, see, we got a 2x and an x there, and then let's see, let's go -1 and +1. I got it? Yes, indeed. Okay, so now it's factored. Now I'm going to set each of those terms equal to 0 and solve for x. So that's going to give me x is equal to -1 and x is equal to 1/2. So I'm going to make my consider list. And I've got an endpoint at -2. And I've got one of my potential critical points at -1. And one of my other potential critical points at 1/2. And then the other endpoint was at 1. So I'm considering these 4 values.
Do we not consider negative?
And I'm going to do a sign chart on this one because it will help me a little bit. So let me make a sign chart real quickly of the derivative. See, I got -2, 1, and then that's -1, and that's 1/2. And so I'm plugging values into the derivative. And I'm going to plug it, it doesn't matter, but I think it's easier if I plug the values into the factored form of the derivative. So if I pick a value between -1 and -2, let's say -1.5, that would give me -1/2 here, and then that would give me a negative value here, and so negative times a negative, that gives me a positive. And then I'm going to pick a value between -1 and 1/2, let's say 0. I'll pick 0 and plug it in for x, that gives me 1 and times -1, so that's going to be negative. And then I want to pick a value between 1/2 and 1, let's say 3/4. That would give me a positive value for this term and a positive value for this term. So that's going to be positive.
So you plug it in and say no.
Yes, plug it into the derivative, into both terms there, and then you're checking the sign. And so now that I have a sign chart, I can eliminate that one.
Why?
That is a good question. Why can I eliminate -1? What did the question ask for? The absolute minimum. And I know that there is no minimum at -1 because of my sign chart. It is increasing on the left side. It goes up and then it goes down. So there has to be at least a local max at -1. I can also eliminate that one because it is increasing and then it stops at the end point. Therefore, there also has to be at least a local maximum at 1. So my only 2 possibilities now are -2 and 1/2. And so I'm going to take those values and plug them back into the original function and see which one is the lowest, and that will give me my answer. So if I take -2 and plug it in, let's see, that gives me -8 times 4, that's -32, and plus 12, and plus 12, and plus 1. So let's see, I've got -2, and then that's going to give me -32 plus 25, which is -7. So I'm going to stop there because that's the answer, right? There's no other value that's lower than -7, so that has to be the absolute minimum.
What about the 1/2?
Well, look at the answer choices,
Oh,
okay? If this were a free response, then yes, I would have to plug in 1/2 and evaluate it. But since it's multiple choice, there's no other value that's less than -7. So it has to be that. Yes.
Okay, so why did you cross out the 6? Like, why wasn't there, like, why wasn't x equals 0 considered a point? Like, what is factor?
Okay. When I factor out the 6, algebraically, I can divide by 6 on both sides. Algebraically, correct? So when I do that, if I divide by 6 on this side and I divide by 6 on this side, I have 0 divided by 6, which is 0, and then 6 divided by 6 is just 1. Therefore, the 6 goes away.
Also, it's not in the what's not.
Just